Okay, so one of the factors that will play a role in the growth of bone will be hormones. And hormones are chemicals that are released into the bloodstream by endocrine glands. And remember, all the way back into chapter 1, we talked about the different body organ systems. And one of those systems was the endocrine system. And it's the hormones are released by endocrine glands. Okay? And so some of the hormones that will play a role in bone growth, the first one being growth hormone. Growth hormone is released by the pituitary gland. The pituitary gland is a small glandular structure that hangs from the base of the brain, all right? And what growth hormone does is it affects both longitudinal as well as appositional growth. So growth in length as well as width of bones. And it does this by, just as the name implies, growth hormone will increase the rate of mitosis. So cell division, mitosis of the chondrocytes in that epiphyseal plate. It increases the activity of osteogenic cells like the osteoblasts, right? The osteoblasts that invade into that zone of ossification and lay down new bone. And directly stimulates osteoblasts in the periosteum, which triggers that appositional bone growth. So what is growth hormone? It's a chemical released by the pituitary gland of the brain. And the main role of growth hormone, and as it plays in bone growth, the main role is to increase cell division of chondrocytes and increase activity of bone cells like osteoblasts, both in the zone of ossification for that longitudinal growth, as well as direct stimulation of osteoblasts to lay down new bone in the periosteum, which triggers that appositional growth, or the growth in width. Other hormones that play a role are the sex hormones like testosterone, which is the main male masculine sex hormone. This is produced by the testes in males. Estrogen, which is primarily going to be produced by the ovaries in females. Okay, so testosterone in males, testosterone will help with increased appositional growth. So appositional is growth in width, right? So the bones, that's why men on average will have thicker bones and denser bones, because it also triggers more calcium deposition. So males usually have thicker and harder bones. Increases the rate of mitosis in the epiphyseal plate. That's why upon puberty, males will have growth spurts, especially in the teenage years with the onset of puberty. It also accelerates the closure of the epiphyseal plate. So upon reaching puberty, when you start to have growth spurts, over time, the more and more testosterone that's produced by the male will lead to closure or ossification of that epiphyseal plate. And that's why males will stop growing in length around 25 years of age. Now, the female sex hormone estrogen increases the rate of longitudinal bone growth by inhibiting osteoclast activity. Well, what do I need? I want you to know that it increases the rate of longitudinal growth, whereas testosterone really plays a role in that appositional growth, is stimulating appositional growth. So estrogen will increase the rate of longitudinal growth. It also, estrogen leads to growth spurts. So the same with testosterone in males. Around the onset of puberty, when estrogen starts being produced and released into the bloodstream, you'll see growth spurts in females. Now, why are females on average shorter than males, and why is the average age in which all bones are ossified, why is it 23 for females and not 25 like for males? It's because estrogen accelerates the closure of the epiphyseal plate. So it's much more potent in the ossification of the epiphyseal plate than testosterone. So whereas they both stimulate these growth spurts, right? They both stimulate growth in length. Estrogen has a more potent effect on ossification at the epiphyseal plate, and the faster an epiphyseal plate ossifies will then you can't grow as tall. I hope that makes sense, okay? So that was what leads to the average height difference between sexes, males and females. And then this is just talking about what happens if you have excess growth hormone. Usually excess growth hormone will be because of some sort of tumor on the pituitary gland in the brain. Now, if you have excess growth hormone in childhood, like early childhood, this can lead to a condition called gigantism. And so you get really tall individuals. Whereas if excess growth hormone happens into adulthood after the epiphyseal plates have already closed, you can't have an increase in height at that time, so you don't get gigantism. You get a condition called acromegaly, and this is where you don't have growth in length, but you do have enlargement of bone, cartilage, and soft tissues. So, and the bones of the skull, face, hands, feet, and tongue are usually the most affected. And so individuals with acromegaly will have very large, you'll see a profound difference in, if you were to look at pictures of a younger, like early adulthood picture of that person versus after the onset of acromegaly, in much enlarged nose, enlarged face, enlarged and distorted hands and feet as well. I'm not going to ask this on the test, but if you want to read about, this is a clinical application of what you're learning.